Hi everyone. So in this video we will learn about the direction of angular velocity. So let's say we have this object P and this object moves in a circular direction, right? And let's say we have this I, J, K axis. So the object moves in the IJ plane in counterclockwise direction about this let's say origin O. So we define angular speed as the rate of change of angular displacement with time. So this we know already, right? Now, just like we have linear speed and we have linear velocity, same way we also have when an object moves in a circular path, we have we associate angular velocity with it. Now, if we associate angular velocity, it should also have a direction. So let's try to understand the direction of angular velocity, right? So when an object moves in a circular path, what is the direction of the angular velocity? So let's first, define the r vector, the position vector of the particle. So what we will do is we will first calculate the velocity, right? The linear velocity of this particle. Let's first try to calculate that. So to calculate that, what is linear velocity? Linear velocity or velocity is the rate of change of displacement, right? So what is the displacement? We will consider displacement as r vector because the object is at point P. So r vector will be OP vector, right? And what will be OP vector? So let's say the object is at a distance of r from the center. So OP vector will be this vector, right? So this is the OP vector. Now OP vector will have an x component and a y component. So the OP vector can be written as r cos theta I cap plus r sin theta j cap, right? Now we can also write this OP vector as r er cap. So we define a unit vector in the radial direction. So in the direction of r vector, if we define one unit vector, then we can just say that OP vector is equal to r er cap. So in this case, what will be er cap? So er cap, which is a unit vector, it will be cos theta I cap plus sin theta j cap. Now this is r vector, so which is the displacement vector. And what is the velocity? So velocity will be obtained by differentiating this r vector with respect to time. So if we differentiate this term with respect to time t, what we will get? We will get r. When you differentiate it, we will get this term. We will get r omega minus sin theta I cap plus r cos theta. There's no r, plus cos theta j cap, right? So omega is d theta by dt, right? Now, as you see, this velocity has this velocity vector has the x component in the negative x direction and the y component is positive. So this we can visualize also, right? When this object moves in a circular path, so at any instant the velocity vector will be tangent to the circular path. So the velocity vector would be in this direction. Now if you split this in x and y component, so you can see this velocity vector will have this as the x component and this as the y component. So you can see x component is negative, y component is positive. So that is what we get here. Now this velocity, this is a vector, right? Now this v vector can be written as a cross product of two vectors, because we know that the cross product of any two vector is a vector, right? So let's try to write this v vector as a cross product of two vectors, right? Now let's say the first vector is r vector and the second vector is omega vector. So what we are saying is that we are writing this velocity as a cross product of the position vector and omega vector, and this omega vector we are calling as angular velocity. Now we know r vector is r cos theta I cap plus r sin theta j cap. So r vector is exactly that same. Now we need to we need to define omega vector. Now we need to define omega vector in such a way such that the cross product of this omega vector and this r vector becomes equal to this vector, right? So what will be the value of omega vector which will satisfy this condition? So to satisfy this condition, the value of angular velocity or omega vector should be omega minus k cap, right? So it should be omega minus k cap, right? So what we are saying is we are defining omega vector as omega minus k cap, which means the omega vector or the angular velocity vector is perpendicular to the plane in which the object is kind of moving in a circular path, and it's in the, like in this XYZ axis, it's the direction is in minus k cap, right? So now if you do the cross product, you will find that cross product of I and k vector is minus j cap, and minus minus gets cancelled, so you will get cos theta j cap, and cross product of j and k is I cap, so you will get minus sin theta I cap. So now you see, when we do the cross product, this term is exactly same as this term. Now let's say, what if the this object is moving in clockwise direction? So if the object moves in clockwise direction, then what will be the direction of angular velocity? Then the direction of angular velocity will be opposite, right? It will still be perpendicular to the plane, but it will be in k cap direction, right? So that's how we can define the direction of angular velocity.